Hello friends, in the last lecture we had seen the derivation of the equation of line in intercept form which is x upon a plus y upon b is equal to 1, where a is my x-intercept and b is my y-intercept. And second, we saw the equation normal form or perpendicular form. The equation of the same is x cos alpha plus y sin alpha is equal to small p, where p is the perpendicular distance from the origin of the required line, and this perpendicular makes an angle alpha with respect to the positive direction of x-axis. We had seen in the last lecture the derivation of these two equations of the line. So in this lecture we are going to cover the questions pertaining to these two equations. So first question I like to have is, find the equation of the line. Find the equation of the line which cuts off an intercept, which cuts off an intercept 4 on the positive direction of x-axis, on the positive direction of x-axis, and intercept 3 on the positive direction of y-axis, on the positive direction of y-axis. So friends, over here we are provided with the x-intercept as 4 and y-intercept as 3. So I know the intercept form of the equation of line, which is the first one, x upon a plus y upon b is equal to 1. So I'll make the use of this equation of the line and substitute the value of a is equal to 4 and b is equal to 3 in the equation of the line. As I can see that the required line makes an intercept of 4 on the positive direction of x-axis and an intercept of 3 on the positive direction of y-axis. Hence, we can say that the value of a is equal to 4 and value of b is equal to 3. Substituting these values of a and b in our equation x upon a plus y upon b is equal to 1, we will get x upon 4 plus y upon 3 is equal to 1. By taking LCM of this, I'll get 3x plus 4y upon 12 is equal to 1, which is 3x plus 4y is equal to 12. So this is the equation of the line which we are required to find out. Moving on to the next question is, find the equation of the straight line. I'll write it in the short form. Find equation of the straight line whose intercept on x-axis intercepts on x-axis and y-axis are respectively twice and thrice of those by the line 3x plus 4y is equal to 12. 3x plus 4y is equal to 12. So friends, over here we need to find the equation of the line whose intercept on x-axis and y-axis are twice and thrice respectively of those by the line 3x plus 4y is equal to 12. Now the solution of the same, we are provided one line 3x plus 4y is equal to 12. In the intercept form, I can write this line by dividing 12 on both the side. I'll get 3x upon 12 plus 4y upon 12 is equal to 1, which means that x upon 4 plus y upon 3 is equal to 1. So in the intercept form, I had denoted my given line in this way: x upon 4 plus y upon 3 is equal to 1. So by comparing the intercept form, I'll get a is equal to 4 and b is equal to 3. Now, a required line have x-intercept as twice and y-intercept as thrice of the given line. Now, for the given line, we are provided x-intercept as 4 and y-intercept as 3. So for the required line, I'll get, let's say, a dash is the x-intercept which the required line form with the positive direction of x-axis. Then a dash is equal to twice that of a, which is equal to 2 multiplied by 4. By substituting the value of a equal to 4 in this equation, I'll get a dash is equal to twice of a. So a into 4, that is 2 into 4, is equal to 8. So a dash is equal to 8. Let's say b dash is the y-intercept which the required line makes with the positive direction of y-axis. Then, as per our given question, b dash should be equal to 3 times that of b. So I'll write b dash is equal to 3 times that of b. Now substituting the value of b equal to 3 in our expression, b dash is equal to 3b, we'll get 3 into 3 is equal to 9. So b dash is equal to 9, and over here I'll get a dash is equal to 9. Hence, the x and y intercept of the required line are 8 and 9 respectively. Then the equation of the required line is x upon a dash plus y upon b dash is equal to 1. Substituting the value of a dash and b dash as 8 and 9, I'll get x upon 8 plus y upon 9 is equal to 1, which implies that 9x, by taking the LCM, I'll get 9x plus 8y is equal to 9 into 8, 72. 72 I'm getting the denominator, and hence the equation of the line becomes 9x plus 8y is equal to 70. So this is the equation of the line which we were required to find out. Let us see one more questions pertaining to the intercept form itself. Find the equation of the line. I'll write it in the short. Find equation of line which passes through the point 3, 4 and the sum of its intercept and the sum of its intercepts on axis is 14. On axis is 14. So friends, over here we are provided that the required line passes through this point 3 and 4 and the sum of its intercept axis is 14. Let's say let A be the x-intercept which the required line makes with the positive direction of x-axis, and B be the y-intercept which the required line makes with the positive direction of y-axis. Hence, the equation of the line becomes x upon A plus y upon B is equal to 1. Let us put this equation as number 1. Now, we are provided that our line passes through the point 3 and 4. Hence, 3, 4 should satisfy the equation number 1 of our line. Hence, we will get 3 upon A plus 4 upon B is equal to 1. Since these points This point with the coordinates x coordinate as 3 and y coordinates as 4 satisfies the equation of the line. So I'll put this equation as, now we are also provided that the sum of its intercept on the axis is 14. Now we had already taken A as the x-intercept and B as the y-intercept, and the sum of these intercept is 14. Hence I can say that A plus B is equal to 14. This implies that A, or rather I'll put B is equal to 14 minus A. Now substituting this value of B in equation number 2, my equation number 2 becomes 3 upon A plus 4 upon B, where B becomes 14 minus A is equal to 1. Now by taking LCM, I'll get 3 times 14 minus A plus 4 times of A upon A into 14 minus A is equal to 1. This implies that 3 times 14 minus A plus 4A is equal to A into 14 minus A. Expanding the bracket, I'll get 14 into 3, that is 42. A minus A into 3 is equal to minus 3A, plus 4A is equal to 14 into A, that is equal to 14, and minus A into A, that is equal to minus A square. Now simplifying these equations, I'll get A square. I'll take A square on the left hand side, it becomes positive A square. I'll take 14A to the left hand side, it becomes minus 14A, so I'll get minus 3A plus minus 14A, that is minus 17A, minus 17A plus 4A, that is equal to minus 13A, plus 42 is equal to 0. So factorizing this further, I'll get A square minus 7A minus 6A plus 42 is equal to 0, which can be further factorized. I'll take A as common, A minus 7 minus of 6, A minus 7 is equal to 0, which implies that A minus 7 of A minus 6 is equal to 0. Hence, I'll get two values of A minus 7 into A minus 6 is equal to 0. Hence, either A minus 7 is equal to 0 or A minus 6 is equal to 0. So first case, I'll take A minus 7 is equal to 0. This implies that A is equal to 7. Second case will have A minus 6 is equal to 0. In that case, A is equal to 6. Now, I have two values of A. We know that B is equal to 14 minus A. I'll substitute the value of A equal to 7 and A equal to 6 in this equation. I'll get two different values of B, for one for A equal to 7 and the other for A equal to 6. So substituting the value of A equal to 7, I'll get 14 minus 7. So B is also equal to 7. Over here, substituting the value of A equal to 6, I'll get B is equal to 14 minus 6. That is B is equal to 8. So substituting these two values in our equation number 1, that is x upon A plus y upon B equal to 1, I'll get two different equations of the line. One would be x upon A over here is 7, so x by 7, plus y upon B is also 7, so I'll put B also 7 is equal to 1. Hence, taking LCM, I'll get x plus y is equal to 7. In the second case, I'll substitute the value of A equal to 6 and B equal to 8. In our equation number 1, I'll get x upon 6 plus y upon 8 is equal to 1. Again, taking LCM of this, I'll get 4x plus 3y is equal to 24 are the required equation of the line which we were asked to find. Now friends, we'll see the questions pertaining to the normal form of the line. Let us see the first question. Find the equation of the line. I'll write it as in the short form find, F for find, T for the, E for equation, find the equation, O for of the line. I had written the in the short form find the equation of the line which is at a distance, which is at a distance 3 units from the origin and the perpendicular from the origin and the perpendicular from the origin to the line makes an angle of makes an angle of 30 degree with the positive direction of x-axis, with the positive direction of x-axis. So friends, we are over here provided that the line, our required line of which we are need to find the equation of, is at a distance of 3 units from the origin, and this perpendicular makes an angle of 30 degree with the positive direction of x-axis. So we had seen in the starting of this lecture that the normal form is this x cos alpha plus y sin alpha is equal to p of the equation of the line for which the perpendicular is p, and that perpendicular makes an angle of alpha degree with respect to the positive direction of x-axis. Hence, as per our given question, we can say that p over here is equal to 3 and alpha is equal to 30 degree. So substituting the value of p and alpha in our normal form or normal equation of the line, we will get x cos alpha plus y sin alpha is equal to p. Hence that would become x cos 30, where alpha is equal to 30, plus y sin 30 is equal to p, where p's value is 3. Now I know that x cos 30 is equal to root 3 by 2 plus y of sin, I know that sin 30 is equal to 1 by 2 is equal to 3. Taking LCM on both the sides, I'll get root 3x plus y whole upon 2 is equal to 3. This implies that root 3x plus y is equal to 2 would get multiplied with 3, and we will get the required equation of the line which we were asked to find out, which is equal to root 3x plus y is equal to 6.